Hello everyone, and it's great to be here at NahamCon, and I'm going to be teaching you how to actually find your very first bug with API hacking. And this is going to be kind of like a short whirlwind whistle-top tour of API hacking, and I'm hoping by the end of this talk you'll feel like confident enough and interested enough to try and start hacking APIs yourself. I would love for you to go away and start API hacking alongside me and get some bugs. So my name is Katie, also known as Insider PhD. I am a hacker and a YouTuber. My hacking specialty is APIs. I found a lot of bugs in APIs and mobile APIs. I used to make APIs, I used to be a developer, and now I break them. So I really use my developer background in order to help my hacking. I have a ton of videos on API hacking on my YouTube channel. So if you want specific instructions, go there. This is not going to give you everything you need to know, but hopefully give you, a little push, a little push in the right direction. I would love for you to go away from this and actually have a go at API hacking. I think they are really great places for beginners to start with because you don't need a lot of technical skills. Now, don't get me wrong, that's not you need no skills. That's you don't need technical skills. You're not going to lose out to automation. And that's why I think there's some of the great bugs. But if you want to see more on this, you want to see more demos, tools, bugs, more in depth, my video on a single API vulnerability is like an hour long. So this is going to be a short version of that. So why APIs? Why do I and other hackers focus on APIs? What makes them great? So APIs are a very common design pattern for modern web applications and mobile applications. And that's because the developer only has to write the business logic once in the API, and then whatever app that they're using, they just need to connect to that API, meaning that if you want to launch a mobile app and a web app at the same time, well, if you use an API, you're only writing that logic once. So it's really common for a lot of, especially startups that are just starting out, to just throw an API together. Another thing is that if they have developers, they will often have a public facing API as well to enable connections with stuff like if this then that, or just third parties as well. Now there's also new technology like GraphQL which are changing how APIs work, and that's actually good for us as a hacker because that design and the secure design isn't as well known as something like a traditional web application. A lot of hackers often have a lot less familiarity with APIs, and although the bugs aren't significantly different, in fact they're basically the same, APIs can be really intimidating for other hackers, and people just don't feel comfortable with looking at, say, technology that maybe they don't understand, they've never worked with. APIs expose a really large attack surface, especially with what I'm about to suggest to you, which is corporate APIs. So with that large attack surface, there's a ton of API endpoints that may have even been generated, so generated using a tool or a framework rather than being designed by a software engineer. And what that means is because that's such a large attack surface, that you are never going to be able to keep how an API works all in your head. You're going to have to take a step back, especially with enterprise applications. Now, a lot of the fixes that go into APIs often end up fixing the client side. So maybe they stop you from being able to type in JavaScript into a box, but they don't actually stop the API from processing that input. So because stuff is fixed on the client side but not server side, it initially looks like the vulnerability doesn't work. But actually, when you go into it and when you actually look at it, it hasn't actually been fixed. So APIs can be these really great attack surfaces that are changing all the time, that are super common, that have really large attack surfaces, and that people aren't actually looking at. A lot of people will also think API hacking is a completely different skill. And in some cases, hacking is completely different skills. You are not going to be a browser hacker from being a web hacker. They are very different skills. And even mobile. Mobile is kind of a different skill as well. But APIs are just web applications. They fall victim to exactly the same security flaws as regular web applications. They just look different and they're in different places. So step one, pick the right target. So my best target for starting out API hacking, you want a large attack surface, but potentially not enterprise level. Because cloud stuff where you have tenants, can get really complicated very quickly, which is good for hackers because that means that we're not competing as much because there's way more endpoints to look at, but it's really hard to keep that in your brain. So I really like things like the Yahoo. So Yahoo has a bunch of these little mini applications. All of them use APIs and they all log in via the login.yahoo.com. It's like Google, right? But there's these little pockets of functionality that say Yahoo Mail. That's got a mail API. So you could experiment with a kind of limited API, but you're still kind of taking in that whole idea of like the kind of big attack surface that exists when you start to include things like their news articles or whatever. Another one I recommend is Tumblr. Tumblr has this big monolithic API. So while there are different functionalities like having a blog and reblogging and stuff like that, that all takes place within the same API. These are really great to get started with. I know this seems counterintuitive. I know it's like, that's way too much stuff happening. But you don't want to attack something with a small surface area when you're starting out. Because you want to be finding those niche features. So you, one, have a greater chance of finding something. And two, when you do find something, you've got a greater chance of it not being a duplicate. Anything that has a mobile app and a desktop app are usually really solid choices, though. And certainly, this is not exhaustive. Now, if you search through the scope and just look for API, you may not even see that in the scope. So just double check that the API, one, is in scope, it should be, and two, that you're not accessing like a third party. So Recon, I think a lot of people overcomplicate Recon, and maybe this is because I'm at NahamCon, and obviously Nahamsec is quite well known for his Recon, but just don't overcomplicate it. Don't try and run like 5 different tools to search for subdomains. When we're doing API hacking, we don't need to do that. Now, one of the reasons why we don't want to do this is because APIs are really made for humans and developers. So if you end up searching for, say, I don't know, using Dirbuster, all you're going to find is a bunch of like 404 errors because that's not how APIs work. That's not what API routes look like. So don't overcomplicate it. What I would suggest is you try and find the rarely used features in the app. Like go into hamburger menus, go into settings, pay for more access, if that's affordable. You don't need anything else other than burp. You just want to explore what the API can do, essentially. Next up, you're going to have to learn how to read Json. So Json is this data structure on this side here. Now, I find it very easy to read, but I also used to make these. So you can actually get this tool which turns your JSON into a graph, and that can make it really easy to visualize these complex trees. You can also use something called JQ, which is a command line tool to help you as well. But this really helps in like understanding JSON, and you do have to understand it and read it, especially when you start talking about actually hacking stuff. So depending on the API kind of style, there are different ways of making requests. But this, I promise, is nothing more than just look at how the other requests are being made. So look at what your valid request that does something because you clicked on it in like the application, look what that does, and that will teach you how to structure requests. Now, often you'll see either RESTful APIs, which are far more common, and GraphQL, which are becoming more common. But initially, just focus on the functionality you can see in front of you. Don't try and overcomplicate things. Don't try and push to kind of use a bunch of tools. Look at what's in front of you. Hack what's actually in front of you. Notes are so helpful for making sense of a complex API. And the way I like to do it is using something like a spreadsheet. So I will have the method, the endpoint, and then the vulnerabilities that I'm looking at. Though, to be honest, broken function level authorization and privilege escalation in this case are the same. But looking at something like this, where you can break down tests on each individual endpoint, can be huge for, one, helping you make sense of a complex API, and two, actually working out what you've tested before. So you can still tick things off, you can still get progress, and that can be really motivating, especially when you're first starting out, and you feel like, oh, I tried hacking and it went horribly because I didn't find anything. And that makes you demotivated when actually Like, sometimes that happens in hacking. You don't find anything. It's totally normal. So these are the 4 issues I recommend looking for. So first is access control, IDORs, bowlers, both, whatever you want to call them. Broken authorization issues. So whether that is cross-user permission issues or cross-tenant, so can you do something to somebody else's account? Can you do something to an organization where you're not a member of it? Can you do a high permission level thing, like for example an admin action as a regular user? All of those, access control. There's a bunch of different ways to test for these, but I really recommend the cookie trick, which I'll talk about in a second. Mass assignment. So mass assignment is the idea that an API will be able to set certain values even though they shouldn't be set. So for example, the ID on a database shouldn't be something a user can edit, but in mass assignment it is. Another example is often passwords. So if you go through the proper flow, when you want to reset your password, you have to provide your old password, then you have to make sure your password meets the requirements of the website, whatever. Or maybe you can just go to edit profile, add a parameter called password, and it just works. Information disclosure. Honestly, one of the most simple bugs, requires you to use your brain a little bit and work out if you're looking at something that's sensitive. And business logic errors where, for whatever reason, you can skip over steps. You can set your accounts to be in weird permission states. Really common with permission hierarchies when we start speaking about enterprise software, where you have organizations have members, and members have permissions that associate with that organization but shouldn't be associated with other. You get the idea. Complexity breeds business logic errors. So access control. So to test for access control, you have to make some accounts. Now, I recommend having 3 accounts: an admin user, if you can have an admin user, a regular user 1 and a regular user 2. If you can't have an admin, then it's just 1 and 2. So you want to do requests on the first account, so that's regular user 1, and see what happens. So, edit a post, search post, create post, whatever. Now, if you change out regular user 1's cookie in that request for the cookie used for regular user 2, does that still affect regular user 1's account? Now, note, if it affects regular user 2, that's fine. If we have, say, a create post endpoint, and if we use user 1's cookie, it creates a post on user 1's account. If we use user 2's cookie, it creates an account on user 2's posts account. That's fine. That's working as intended. That's not a vulnerability. If we can use regular user 1's request with regular user 2's cookie, and it makes a post on user 1's account because it's got something else in there, maybe it has an account ID or a user ID or something, that is our broken access control. And it's really important that you understand that before you submit a vulnerability that's access control related, because you might find that gets NA'd. Because if you are going in there and saying, well, it's affecting user 1's account with user 1's cookie, yeah, it's supposed to. It's only if you can impact another account with a cookie that it counts as access control issues. So some of these are going to be needing permission levels. Now, anytime you're looking at really complex, you're going to need a spreadsheet, and you're going to need to note down what permission levels you have to have. And essentially, even if you're testing other users, tenants, or more complex permission levels, especially when you start assigning permission levels, you're essentially doing the same thing. Can user 2 repeat user 1's request and still affect user 1? Okay, so user 2 is able to affect user 1. Again, if you're testing tenants, you want to make sure you have more users and different tenants, and you want to see whether or not a high permission level in tenant 1 can affect the tenant 2, for example. Again, this is an entire class of vulnerabilities that I am boiling down for you, but probably one of the most common issues I see in APIs. I could essentially throw a dart at a wall or pick up an API and I'd find one of these bugs. The reason why you tend to find them is because it's really hard to automate those very quickly. You can use things like Autorize, and there's some other burp add-ons that can do it as well. But it still has something you have to test for manually. You need to use your brain. Mass assignment. So on a GET request, you can see when you have, this is the GET request. Here we're making a GET request for API deliveries, and the response has the ID, a created at, an updated at, and a user ID value. Okay. So if we do our put request to API deliveries and we make sure the content type is JSON, we can copy what I've got in gray to the body of that request and change it. So this is a great way to test for these because you can copy and paste large amounts of JSON very, very easily. Now, if, let's say, user ID here was able to be affected, so it did actually change from 7 to 1, that would be a mass assignment type vulnerability. You can also argue it would be an access control issue, or like a permission issue, but this is how you test for mass assignment. So you can imagine if this was users, maybe you try and assign a password, maybe you would just try and ascribe an API key. You can just copy paste and then change this a little bit and see whether or not it still works. Now, if something doesn't change, if you put this in and nothing changes, then you do not have a mass assignment type vulnerability. If it is assignable, like as in it's not in a form, but you can do it via the API, that's a mass assignment vulnerability. Information disclosure. Read the JSON. Is it sensitive? And if so, what is the impact of it? If yes, report it. Best thing you can do is become familiar with things like GDPR to make an argument for personal data. Though I will say in every single situation I've seen information disclosure vulnerabilities, it's been really easy to tell because it's just very obvious that this has too much information. Now, something else that's worth pointing out here is that often your information disclosure might be more to do with the client. So if you, say, are playing, a game, and you were able to, cheese a mini game that would give you credits, then that could be information disclosure in the sense that that would allow you to kind of figure out information about how that game works or allow you to win every time. That can still be information disclosure even if it's not personal data. Information disclosure is a very broad definition. Business logic errors. Easiest way to do this is to walk through the features of an API and try to skip over steps. So the way I do that is I will go into burp, I will label, maybe like if I'm taking an e-commerce website, I'll label request to put things in cart, request to check out, request to put in shipping information, and I will walk through that one step at a time and see what is actually changing. So, for example, how does the website know that I've paid? Like, what is it actually choosing for me to do that? What does it mean for having an order that's in this, pre-ordered state? How does it become from pre-ordered to confirmed? Like, what API requests, and can I call those API requests myself? And this is actually how I found my first ever vulnerability. It was one of these kinds, and it was because I stepped through those steps one at a time. Particularly in conflicting rules, like access control rules, where you have implied permission levels, this can happen quite a lot. So, for example, a guest user that can edit their email but can't actually read their user details because they're a guest. Things like that tend to be very, very common in APIs. And again, this is how I found my first vulnerability. Or literally my approach was put things into repeater, go through the steps one at a time, and then try and skip over one of the steps and look and see, maybe you could put in a negative quantity, for example. That's also a very common one on e-commerce websites. Now, the final bug is really input sanitization issues. So common on mobile apps. So people will don't realize that you could type a cross-site scripting payload into a mobile app, and then when you access it on the website, it will actually still render that JavaScript because it's you're not going to do XSS on your phone. Very common in APIs as well. You're not going to access the API on your device, so we're not going to do any input sanitization. Well, by the time you then load it up on your phone, would you look at that as cross-site scripting? Again, this is usually like the usual suspects like cross-site scripting, XS, even very simple XSS payloads tend to be like quite common in APIs. Now, the way you know it's not vulnerable is if you see the what is it, the alt code thingy, like the less than, greater than. If you see that, it's not vulnerable because the website isn't actually rendering that. So it doesn't matter what you put into the API. If it's not being rendered as JavaScript, it just won't work. So finally, some advice. API hacking is much more about volume of requests that you can make than skills. You don't need complex technical skills. You don't need to be a super mega genius. However, that means they take time to hack manually. And as beginners, what we have most of all is time and patience. You are going to find duplicates, and that is okay. Duplicates mean you were good enough as a hacker, you just weren't fast enough. Every other hacker that's spoken today, every other hacker that's making like top stuff on BugCrowd or HackerOne have got duplicates. We don't just get no dupes, right? It's very normal to get duplicates. Now, I would really try and focus on bugs that you can do manually rather than automation, because when you have a very automation-focused approach, somebody else has probably already automated it and has scaled it much more than you have. Complex APIs are your friends. Complex APIs are really hard to learn, really hard to use, but because of that barrier, because they're a bit more challenging, people just aren't hacking them. And like I say, as beginners, we've got time. We've got the time to learn these. We've got the patience and kind of the motivation to still do this, right? So get out there, get API hacking. Thank you so much for listening. Hopefully this has inspired you to start API hacking. I'd love for you to give it a go and let me know how it all goes. And if you find your first bug, please send me a tweet. I'd love to read about it. Thank you very much, everybody.